Hello, my name is Miranda. In today's presentation, we will be discussing the various aspects of base 3, including conversion to decimal, multiplication, and addition. In this first example, we will be converting 4 into base 3. The highest power that goes into 4 is 3. So we have one set of 3, and then there's one left over, so we have one set of 1. In this next example, we have 23, and the highest power that goes into 23 is 9, and it goes in twice, so we have 18. 23 minus 18, we get 5. 3 goes into 5 one time, we have 2 left over, and 1 goes into 2 twice. In this next example, we have 35. 27 goes into 35 once, so we have one set of 27, and we have 8 left over. 9 doesn't go into 8, so there's 0, and then 3 goes into 8 twice, so we have 2 sets of 3, and then we have 2 left over, so we have 2 sets of 1. In this last example, we will be representing this number in base 3 blocks. So we have one set of 27, we have one set of 9, we have 0 sets of 3, and we have 2 sets of 1. So in total we have 127, 1 9, and 2 1s.
Hello, my name is Yesenia, and now we are going to be converting the number of base 3 to base 10. In order to complete this process, we would have to multiply the number by its place value. Now, starting from right to left, we're going to multiply 2 times 1, which is 2, 3 times 0, which is 0, 1 times 9, and 1 times 27. Once we get the products, we're going to add them. So 27 plus 9 plus 0 plus 2 is 38, and that is your base 10, and that's the decimal of this base 3 number. Now let's look at another example. We're multiplying 1 times 1, 0 times 3, 2 times 9, and 1 times 27. Once we get the products, we're going to add them, and we get our base 10 number. Conversion to base 10. We are going to be performing addition of these two base 3 numbers using the base 3 blocks. If we take a look at the first number, it shows that there are 2 1s, 1 3, and 1 9. Now if we see the second number, it has 2 1s, 0 3s, and 2 9s. Now let's look at the blocks here. These 3 show that they can be converted into 1 3. And in the 9th place, there are 3 9s that could be converted into 127. So now we have 1 set of 27, 0 sets of 9, 2 sets of 3, and 0 sets of 1. Now let's convert it to base 10. We're going to do the same thing that we did on the previous problem. We're going to add the products, and that will give us the base 10 number. If we compare what we did here, convert each number into its own decimal, we add them, and we get the same thing for both.
Hello, my name is Jennifer, and we're going to be performing the addition for the following two numbers as shown on the paper by using the lattice addition. As Miranda and Yesenia had shown earlier in the video, it's going to be the same process when you're adding the two numbers in order to get your result in base 3. The only difference in the lattice addition is that we are going to be using this kind of a chart, which represents this block right here represents ones, and this one represents tens. Now, you can pause the video here, do the math yourself. I, however, did the math already ahead of time. Also, another thing to note in the lattice addition is right here we are going to be adding diagonally. Just gonna highlight the first three as an example. 1, there's nothing to add with 1, so it stays the same. 0 plus 1 is 1. 2 plus 1, however, remember, since we're doing in base 3, 2 plus 1 equals to 3, which in this case you can't put 3. It's going to be 10. Now what you're going to be doing is that you're going to be putting the ones here, carry the 1 up here, and add it in the following box. In this case, 0 plus 1 equals to 1. Now the same process is the same throughout the entire lattice addition chart. You can double check it yourself, but as shown right here, this bottom part where it says total should be your answer.
Since we've already practiced using the lattice addition method, we're going to be using the lattice multiplication method by multiplying 20 by 12 in base 3. So we start off with 0 times 1 is 0, 2 times 1 is 2, 0 times 2 is 0, and 2 times 2 is 4. Since we're talking about base 3, 3 goes into 4 one time, so it gets carried over and the other one stays behind. Now, once we get the multiplications, once we fill in the table, we're going to be adding them diagonally. So it will be 0, 1, 3 will be carried over and will turn into 1. This number converted into decimal is 30. If we were to convert each one by itself, it would be, we're going to multiply by its base, so it will be 6. Move on here, multiply by its base, and we get 5, because it's 3 plus 2, 5, and you multiply and you get the same thing as you would get in the first one.
Now we are going to be comparing and contrasting base 3 to base 10. Base 3 is represented by numbers 0, 1, and 2. However, in base 10, the numbers that it is represented by range from 0 all the way to 9, not including 10. The block size also differ between the two bases. In base 3, block size starts from 1, 3, 9, and 27. However, in base 10, the block sizes are from 1, 10, 100 to 1,000. Now, the similarity between the two is that the same procedure can be used in the lattice addition and the multiplication. Even when you're also converting the two, it's the same procedure. And this concludes our aspects of base 3 functions.